I would like to make an added point that comes home to me very clearly. Having been involved in some 44 aircraft development programs and 20 in the Skunk Works, I've seen time and again where the United States industry, the aircraft industry, or any other you want to choose, has demonstrated that when it knows what it is going to produce, it can't be beat. The Lockheed Martin Corporation of today can trace its history back to 1912, when the brothers Alan H. and Malcolm Lockheed established the Alco Hydro Aeroplane Company in San Francisco, California. In 1916, Alan and Malcolm moved their enterprise to Santa Barbara, California, and renamed it the Lockheed Aircraft Manufacturing Company. The firm went on to produce a few aircraft, namely the Model F-1 flying boat and the Model S-1 sport plane. The latter was of the advanced monocoque design that, due to its prohibitive price tag, couldn't compete. Thus, without any airplane orders, Lockheed Aircraft was forced out of business in 1921. In 1926, Alan Lockheed, John Knutson Jack Northrop, and Kenneth Ken J. teamed up and formed the Lockheed Aircraft Company in Hollywood, California. The spelling of Lockheed was changed to Lockheed to prevent mispronunciation. Northrop had joined Lockheed Aircraft in 1920 as a draftsman, and it was he who had designed the S-1 sport plane. This new company used the advanced monocoque design features of the S-1 to create the Lockheed Vega. The company relocated to Burbank, California in March 1928, and by year's end it reported sales exceeding $1 million. From 1926 to 1928, the company produced more than 80 aircraft and employed more than 300 workers who, by April 1929, were building 5 aircraft per week. In July 1929, majority shareholder Fred E. Keeler sold 80% of the Lockheed Aircraft Company to the Detroit Aircraft Corporation. In August 1929, Alan Lockheed resigned. The Great Depression ruined the aircraft market, and Detroit Aircraft went bankrupt. A group of investors headed by Walter Varney and the brothers Robert Ellsworth, Bob Gross, and Cortlandt Sherrington Court Gross bought the company out of receivership in 1932. The syndicate bought the company for $40,000. Ironically, Alan Lockheed had planned to bid for his own company but had raised only $50,000, which he felt was too small a sum for a serious bid. He should have bid, for he would have won back his company. In 1934, Bob Gross was named chairman of the new company, the Lockheed Corporation, which was headquartered at the municipal airport in Burbank. Court Gross was named co-founder and executive. The first successful aircraft that was built in any number, 141 aircraft, was the Lockheed Vega of 1927, which is best known for its several first and record-setting flights by, among others, Amelia Earhart, Wiley Post, and George Hubert Wilkins.
Alan became a real estate agent after he had sold the company, and I actually bought a house from him. But the team that came in, headed by Robert Gross, contained Hall Hibbert, who was the vice president of engineering in those days, Cyril Chapelet, who was his finance and administration man, and that team had many others, of course. I shouldn't say many. There were maybe all of 10 or 15. And they involved one man that came with the company, Carl Squire, who was the marketing manager, if you will. We didn't call him that in those days, but he was the salesman. And the team put together quite a lot of different ideas to carry the company from its wooden airplane legend, if you will, and the production, for that matter, into the all-metal world, which they could see coming.
The result was the Electra, an aircraft that was to change the fortunes of Lockheed.
I think this was a pretty courageous move. It was a twin-engine airplane. Lockheed had never built a twin-engine airplane. It was all metal. Lockheed had never built a metal airplane. They had a retractable landing gear. They'd done that once, but this was a little different. And it had two tails on it, which, of course, was the beginning signature, if you will, of one of the designers on the place, Kelly Johnson. And that's when I really first got to know something about Lockheed. Kelly Johnson was Hall Hibbard's sort of chief of advanced design, and he had come from the University of Michigan. And in those days, we had no wind tunnels in the industry, or at least none that I know of. And Kelly used the University of Michigan as a wind tunnel. We had a small tunnel in the basement of the engineering building in Michigan, and I was a student assistant at the time. And so I worked on the Electra and the wind tunnel as a student in Michigan. And that's where the two tails were born. It was a good idea, and still is a good idea for a multi-engine airplane, or a bimotor anyway. In any case, I was interested in it. I met Kelly when he came back to the wind tunnel, and so I came to work for Lockheed after I graduated. Well, that twin-engine Electra was quite a risk for the company. The company had been bought for $40-some-odd thousand, and the development time for this airplane was certainly well over a year or so, which is pretty short. And it was a very successful airplane. It fit a niche in the market and continued to fill a niche in the market, and was actually the foundation of the company.
In the 1930s, Lockheed spent $139,400 to develop its Model 10 Electra, a small twin-engine transport airplane. Surprisingly, a somewhat precocious stalker understudy, Clarence L. Kelly Johnson, then doing postgraduate work in aeronautical engineering, who had participated in the generation of the aircraft's tunnel test data, contrarily had concluded its longitudinal and directional control problems were, as he put it, bad at best. In a somewhat remarkable chain of events, Johnson, during 1933, a year prior to the initiation of the Model 10 tunnel tests, had applied to Lockheed for an engineering job. Johnson took von Hayek at his word shortly after the conclusion of Stalker's Model 10 tunnel study. He returned to Lockheed's Burbank, California offices, master's degree in hand, and again asked for employment. Cyril Chapelet, one of the major shareholders in the new company, and Hibbard were the people who actually hired Johnson as Lockheed's 36th employee. It would be looked back upon as perhaps the single most important personnel transaction in the aircraft manufacturer's history. Kelly's debut, shortly after his arrival, was anything but auspicious. In a meeting with Chapelet and Hibbard during the course of one of his first days at work, he told the engineering group their new Model 10 was only marginally stable. Bluntly, he told the group he did not agree with Professor Stalker's conclusions. He felt a better and safer aircraft could be designed. These comments came as somewhat of a shock to Hibbard. A day after listening to Johnson's matter-of-fact declaration, he cornered the neophyte engineer and orally reviewed his academic credentials in a face-to-face confrontation. He felt certain he could repudiate the Model 10 disparities that had been brought to light. Hibbard would recall years later he came close to firing Johnson on the spot. Several months after the encounter, and after concluding Johnson's claims might have some merit, he told the young engineer to return to Michigan and solve the Model 10's stability shortcomings. Some 73 tunnel runs followed, this number being necessary to narrow the sources of difficulty. The idea of attaching controllable plates to the horizontal tail tips surfaced while run number 72 was underway. These auxiliary surfaces, tested during run number 73, worked very well, particularly after the destabilizing wing root fillets were removed. The next step improved control even further. Full twin vertical tail surfaces now replaced the plates, supplementing the original fuselage-mounted vertical tail. Superb directional control resulted. It was concluded later the original vertical tail was unnecessary, and it was removed. Johnson, who until the Model 10 assignment had been working as a tool designer at Lockheed, returned from Michigan somewhat a hero, and most importantly, a full-fledged member of the engineering staff. In solving the Model 10's problems, he had set the company and its product line on the path to financial success. The company sold 40 in the first year of production. The Model 10 would give birth to several perturbations, including the Model 12 Electra Jr. and the highly successful Model 14 Super Electra. Consequently, Johnson would be partially responsible for the financial latitude implied in the prototyping of the Model 22, which later would become world-renowned as the P-38 Lightning. The cutting-edge Lightning was a twin-edge, twin-boom, twin-tail interceptor pursuit aircraft that eventually became a pivotal combat aircraft in World War II. The design and engineering that went into the P-38 were the handiwork of aeronautical engineers Hibbard and Johnson, and the first example, the one-off XP-38, made its first flight on January 27, 1939. Secretly, a number of advanced features were being incorporated into the new fighter, including a significant structural revolution in which the aluminum skin of the aircraft was joggled, fitted, and flush-riveted, a design innovation not called for in the Army specification, but one that would yield less aerodynamic drag and give greater strength with lower mass. As a result, the XP-38 was the first 400-mile-per-hour fighter in the world. It was flown by a USAAC AMC engineering test pilot, First Lieutenant Benjamin Scoville Ben Kelsey, who was a fighter project officer in the engineering division of the AMC and one of P-38's biggest supporters. In fact, he helped convince the USAAC to procure the type. In addition to the P-38 Lightning program, Lockheed Aircraft and its Vega Aircraft Corporation subsidiary, formerly the Air Rover Company, were busy building advanced trainers under license for North American Aviation, the Vega, Electra, and Super Electra airliners, and the Hudson, Ventura, and Harpoon bombers and patrol bombers. In 1939, Howard R. Hughes, Jr., billionaire and major stockholder in Trans World Airlines, TWA, put forth an industry-wide request for a 40-passenger transcontinental airliner with a range of 3,500 miles. The earlier Lockheed L-044 Excalibur design didn't fit the requirements, but lent itself to modification into what became the Lockheed L-049 Constellation. But like so many other aircraft manufacturers of that era, it was constantly looking for new business to survive and to keep its relatively small workforce intact. On order for fiscal year 1940 were 65 P-38 Lightnings and a single Lightning derivative designated XP-49. These aircraft, ordered by the then USAAC, were a mere handful to produce, and additional orders were highly sought after. The year 1941 proved much more lucrative due to the expanding wars in Europe and the Pacific. In 1941, military orders increased dramatically for Lockheed. After December 8, 1941, the date America declared war on Germany and Japan, the floodgates opened, and combat and military transport aircraft soon began to stream off the Lockheed and Vega production lines. Between July 1, 1940, and August 31, 1945, the company produced no less than 19,077 aircraft for the war effort. This figure represented 6.6% of all U.S. production during that period and some 9% of the airframe weight total. By the end of World War II, Lockheed was the fifth largest manufacturer of aircraft in the U.S. The war catapulted Lockheed into the upper echelons of financially successful aircraft production companies. Accordingly, it was unable to indulge research and development initiatives that otherwise would have been all but impossible during more austere times. Most notably, as early as 1939, Hal Hibbard and Kelly Johnson had become somewhat infatuated with jet propulsion theory. The power plant concept, already being exploited with considerable efficacy on the other side of the Atlantic, had been placed on the back burner in the U.S. primarily because of the exigencies of the war. By 1944, however, this was no longer the case. Money was made available for studies and hardware development. Working with Hibbard and Johnson were Phil Coleman, Willis Hawkins, and Gene Frost on airframe development, and the far-sighted Nathan Price on propulsion. World War II ended in Europe on May 8, 1945, though the war in the Pacific raged on for another 4+ months. In the interim, the fledgling Skunk Works was busy trying to improve upon its P-80 series of aircraft while it delved into new designs. It was a time of discord because the U.S. War Department planned to cut back on its numerous high-volume aircraft orders. Wartime aircraft production was about to come to a screeching halt. In any event, inside Kelly's lair, the design, development, and engineering on various aircraft projects were constant. And since he was chief research engineer, Johnson was responsible for all of its wants and needs. With the military market dwindling, it came time for Lockheed to reinvestigate the civilian aircraft market. Its large and elegant Constellation would soon ply the skies throughout the world, but there was a need for smaller, feeder-type airliners to shuttle passengers between major cities. During this particular time period, the still rather fledgling Skunk Works entered into unprecedented territory with the creation of several interesting aircraft projects. Its aerodynamic, aeronautical, electrical, fuel, hydraulic, propulsive, and thermal engineering staff was rampant with genius minds, and they came up with many successful offerings. This team, a precursor to the soon-to-be-born Skunk Works, over a period of 6 months, generated a variety of design studies that eventually resulted in the definitive L-133 jet-propelled, canard-configured fighter. Of all-steel construction with an estimated maximum speed of 600 miles per hour, it was to be powered by 2 Lockheed-designed and built L-1000 XJ-37 axial flow turbojets of 5,500 pounds thrust each. As it was, the L-133 and the L-1000 experience, though seemingly non-productive at the time, eventually would bear Lockheed significant fruit. Both concepts were extremely advanced for the early 1940s, even in the light of parallel German and English efforts, and the axial flow engine in particular would prove prescient from a technology standpoint. More importantly, the small but significant experience base resulting from the Maverick airframe and engine would hold the company in good stead when the Air Force finally realized a legitimate need for a jet-propelled fighter. Jet engine technology in the form of propulsion for aircraft had gone through a relatively long and laborious gestation by the time it was successfully applied to Germany's Heinkel HE-178, the world's first successful jet-powered aircraft. Ernst Heinkel's company had initiated jet propulsion studies as early as 1936 under the aegis of a neophyte engineer by the name of Hans von Ohain. Young and brilliant, von Ohain had been invited to join the Heinkel team and to indulge the theories of jet propulsion that had surfaced while he pursued an engineering diploma at the University of Göttingen. Concurrent with von Ohain's work, and in fact preceding it, was a similar effort undertaken by another young and brilliant engineer, Flight Lieutenant Frank Whittle of Great Britain. Though other British countrymen had begun exploring the attributes of jet propulsion during the same 1920s time period, it was Whittle who first concluded that gas turbine and its pure jet thrust were a practical means of aircraft propulsion. Whittle's January 1930 patent predated all other practical attempts to develop a jet engine, and thus later gave credence to his inventor of claims. In the meantime, von Ohain's work, actively funded by the Nazis, had met with considerable success. His first demonstration engine, the HE-S1, had run for the first time during March of 1937. Around it, the Heinkel Company designed the simple high-wing HE-178 test-bed aircraft. Following its first flight in the capable hands of Heinkel test pilot Erich Warsitz at the company airfield at Mariannhill on August 27, 1939, the HE-178 was used not only to study the jet engine as an aircraft propulsion unit, but also to convince Nazi and Luftwaffe leaders of the jet engine's viability. Its success in the propaganda department later was manifested in the extraordinarily rapid development of such superb operational combat aircraft as the Messerschmitt Me-262 and the Arado R-234, and in turn in the attempted development of a plethora of jet-powered combat types that included the highly advanced Messerschmitt P-1101, Henschel HS-132, the Junkers Ju-287, and the Henkel HE-162. Only the cessation of hostilities prevented German development of a stable of combat jets that could have drastically changed the outcome of the war. On the other side of the Atlantic, U.S. work on jet-powered aircraft had been slow to develop. The reasons were manifold, but in essence they all boiled down to unstoppable momentum in the form of an industrial complex committed to more conventional aircraft forms. On July 25, 1944, Flight Lieutenant A.E. Wall and Pilot Officer A.S. Laban, while flying an unarmed reconnaissance variant of the agile de Havilland Mosquito over Munich, Germany, noticed an approaching enemy aircraft approximately 400 yards astern and closing fast. 5 times Wall turned into the attacking Me-262, but was unable to gain an advantage. It was only by diving into cloud cover that the Royal Air Force aircraft and its crew were able to escape the frustrating battle. When Wall and Laban returned to their home base at Fermo, near Ancona, Italy, they spent little time equivocating over the capabilities of the long-rumored German jet. They were convinced its performance capability was something the Allies could not easily or safely ignore. So little was known about these advanced machines and their performance envelopes, intelligence personnel were hard-pressed to provide Allied combat crews even minimal information. In turn, available information pertaining to jet engine technology was reviewed with renewed interest, including indigenous U.S. research that had been undertaken during the preceding 2 decades. By 1939, enough progress had been realized to convince the British Air Ministry that research funding was appropriate. Accordingly, a contract was led for a prototype engine, the 855-pound thrust W1, to power a proposed jet-powered research aircraft to be built by Gloucester under contract SB 3229. Dated February 3, 1940, and designated E-28-39. During March of 1941, following receipt of a perceptive letter dated February 25th from General H. Hap Arnold, then Deputy Chief of Staff for Air, Vannevar Bush formed a special committee on jet propulsion under the chairmanship of Will Durant, ex-chairman of the NACA and a noted proponent of turbo supercharging. During April of 1941, while meeting with British ministry commanders in England, General Arnold was given the opportunity to see the Gloucester E-2839 testbed aircraft while it was undertaking high-speed taxi tests and short hops into the air at the Hucklecote airfield and review in detail the Whittle jet engine. The display impressed General Arnold. He immediately requested that information pertaining to the aircraft and its unique propulsion system be provided his technical staff in London for detailed review. Concurrently, he advised the U.S. State Department of British jet engine developments and requested it assist in the establishment of diplomatic intercourse that would permit the acquisition and dissemination of jet engine information and technology in the U.S. By early September of 1941, the receipt of British jet engine technology, insights, drawings, and hardware via the technical team assembled under command of General Arnold had resulted in a decision to build a copy of the Whittle jet engine. Almost by default, General Electric was the unanimous choice to build the engine, and Bell Aircraft Corporation, also by default, was picked to build the airframe. The British government agreed to provide rights to the U.S. government and also to provide a single complete engine and one of the two E-2839s. Bell, after submitting and getting approval for its aircraft design, received a contract on September 30th, 1941, for 3 Model 27 aircraft with the military designation XP-59A. Beginning on February 5th and ending on February 18th, 1944, 3 of the YP-59As were used to evaluate the type as an air combat platform, being flown against a Republic P-47D Thunderbolt and a Lockheed P-38J Lightning. Unfortunately for the first 3-generation jets, their performance against their considerably older, reciprocating engine-powered stablemates was abysmally poor. In mock air combat, the P-47 and P-38 proved faster in level flight, capable of higher maximum altitudes, faster in a dive, and with a higher rate of climb. In only one part of the envelope did the P-59s prove only marginally superior, and that was in turn radius. Some 3 weeks after the Muroc evaluations, General Arnold made it official the P-59A would not become the Air Force's first full production jet fighter. Its poor performance, when pitted against contemporary U.S. combat aircraft, did not justify operational deployment. More importantly, intelligence data describing the rapidly evolving German jet aircraft initiative was giving every indication a fleet of fighters with performance capabilities far in excess of those being realized by the Bell P-59 was hurriedly being created. What General Arnold also knew, but few others had been privileged to know, was that Lockheed, some 8 months earlier, had been given the go-ahead on a new jet fighter, unquestionably capable of meeting the Luftwaffe threat head-on. While word of the P-59's demise began to spread, the new Lockheed Fighters Flight Test Program was secretly gathering momentum at Muroc. On May 17, 1943, Hibbert and Price were briefed on the status of jet propulsion development and were invited to submit a fighter proposal around Major Frank Halford's de Havilland H-1B Goblin centrifugal flow turbojet engine. 2 months later, Hibbert and Price were queried during the May 17th meeting as to whether Lockheed might consider designing and building a jet fighter around the British power plant. Due in part to the interest shown in jet propulsion by Hibbert, Johnson, and Price, with their L-133 L-1000 studies during the preceding 3 years and their associated attempts to sell both to the Air Force, it was a foregone conclusion that Lockheed's response would be favorable, and it was. At Lockheed, the new L-140 project started in the middle of an incredibly intense production program that was geared to meet the massive generic needs of burgeoning world war, received only minimal corporate attention. Robert Gross, then company president, and Hal Hibbard, chief engineer, assigned the project to Johnson because of his strong interest in jet propulsion, his established organizational skills, and because he was the most competent of the many young engineers on the company's expansive staff. Johnson, in his autobiography, noted the Skunk Works beginning as follows. For some time I'd been pestering Gross and Hibbard to let me set up an experimental department where the designers and shop artisans could work together closely in the development of airplanes without the delays and complications of intermediate departments to handle administration, purchasing, and all the other support functions. I wanted a direct relationship between design engineer and mechanic and manufacturing. I decided to handle this new project just that way. Putting extraordinary pressure on Johnson and his L-140 XP-80 team at Lockheed was the Air Force requirement the aircraft be completed in 180 days or less. On the 16th, it was noted that Mr. Hibbard came in later to make sure the progress pictures were not faked, and the next day, the entire XP-80 team was told that they could all attend the first flight of the aircraft if they could get it done in 140 days. While the team waited for the new engine, miscellaneous checks were run on the airframe, and work continued on minor sub-assemblies and pre-design for the second and third aircraft, which now were beginning to take shape around a new General Electric engine called the I-40. These improved aircraft, officially referred to by Lockheed as L-141s and by the Air Force as XP-80As, as their design evolved, began to differ markedly from their predecessor. The first prototype, 44-83020, was nicknamed Lulu Bell, also known as the Green Hornet, because of its paint scheme. Powered by the replacement Halford H-1 taken from the prototype de Havilland Vampire jet fighter, it first flew on January 8, 1944, with Lockheed test pilot Milo Burcham at the controls. Following this flight, Johnson said, "It was a magnificent demonstration. Our plane was a success, such a complete success that it had overcome the temporary advantage the Germans had gained from years of preliminary development on jet planes. The donated British jet engine and program data had no doubt proved invaluable." In test flights, the XP-80 eventually reached a top speed of 502 miles per hour at 20,480 feet, making it the first turbojet-powered USAAF aircraft to exceed 500 miles per hour in level flight, following the August 1944 record flight of 504 miles per hour, 811 kilometers per hour, 438 knots, by a special, high-speed variant of the Republic P-47 Thunderbolt. Contemporary pilots, while transitioning to pioneering jets like the Shooting Star, were unused to flying at high speed without a loud reciprocating engine and had to learn to rely on the airspeed indicator. By January 15th, Burcham had conducted 5 flights on the XP-80 for a total of 1.67 hours of flight time. The primary objective of these flights was to obtain preliminary impressions of the XP-80's flying characteristics, as well as information regarding its climb and level flight performance capabilities. A significant amount of flight time also was devoted to evaluating the aircraft's stall characteristics and high-speed performance. The second prototype, designated XP-80A, was designed for the larger General Electric I-40 engine. 2 aircraft were built. 44-83021 was nicknamed the Gray Ghost after its pearl gray paint scheme, while 83022, left unpainted for comparison of flight characteristics, became known as the Silver Ghost. The XP-80A's first test flight was unimpressive, but most of the problems with the design were soon addressed and corrected in the test program. Initial opinions of the XP-80A were not positive, with Lockheed Chief Engineering Test Pilot Milo Burcham commenting that an aircraft he very much enjoyed had now become a dog. The P-80 testing program proved very dangerous. Burcham was killed on October 20th, 1944, while flying the third YP-80A 44-83025. The Grey Ghost was lost on a test flight on March 20th, 1945, although pilot Tony LeVere escaped. Newly promoted to Chief Engineering Test Pilot to replace Burcham, LeVere bailed out when one of the engine's turbine blades broke, causing structural failure in the aircraft's tail. LeVere landed hard and broke his back, but returned to the test program after 6 months of recovery. Sadly, on August 6, 1945, Major Richard Bong, a Medal of Honor winner and the highest-scoring U.S. ace of World War II, was killed in a P-80A while attempting to take off to the south from the Van Nuys, California airport, also apparently as a result of fuel pump failure. After Bong's death, both the USAAF and Lockheed wanted to prove the reliability of the airplane. Thacker tapped Chuck Yeager, plus 2 other pilots, and they put 500 hours on each airplane without further incident. After the war, the USAAF compared the P-80 and ME-262, concluding, despite a difference in gross weight of nearly 2,000 pounds, 900 kilograms, the ME-262 was superior to the P-80 in acceleration, speed, and approximately the same in climb performance. The ME-262 apparently has a higher critical Mach number from a drag standpoint than any current Army Air Force fighter. At least one other important P-80 project became the Skunk Works' responsibility before the rapidly diminishing team moved on to other things. On November 11, 1945, a Gloster Meteor Mk4 of the Royal Air Force set a new world speed record of 606.25 miles per hour. One of the first records of its type to be set by a jet-propelled aircraft, gave rise to an Air Force interest in breaking the record using a slightly modified P-80A. Following a study of the P-80 aircraft by Johnson and various Lockheed and Wright Field engineers, it was concluded a stock P-80A with minimal modification could attain a speed of 615 miles per hour at the required 100-meter maximum sea level altitude. During the course of Chillstrom's numerous passes through the Muroc speed trap, it became apparent that breaking the British record would not be easy. Complicating things was yet another British speed record set by Captain E.M. Donaldson in a Gloster Meteor F4. And the P-80A was not the only U.S. aircraft in the running. Republic's new XP-84, a similarly straight-wing first-generation jet fighter, was proving its mettle at Muroc by running speed trap at speeds in excess of 600 miles an hour, and thus becoming officially the fastest U.S. aircraft. This left Lockheed's Skunk Works modified P-80, now referred to as the XP-80R, as the only U.S. record hope. Some 9 months after the failed October record attempt, the XP-80R was back at Muroc with Colonel Boyd in the cockpit. On June 18, 1947, everything including the weather was at last in place for the ultimate attempt. Guided by reddish smoke flares set off at each end of the course, Boyd passed through the traps 4 different times per the FAI requirement. Speeds of 617.1, 614.7, 632.5, and 630.8 miles per hour were officially logged, giving an average speed of 623.8 miles per hour, and giving the U.S. its first official world speed record in almost a quarter century. The P-80, formerly named Shooting Star by company executives Robert Gross and Hal Hibbert, would go on to have a long and successful career, not only in the U.S. military, but in the air forces of Brazil, Chile, Colombia, Ecuador, Uruguay, and Peru as well. It would lay claim to the first jet versus jet air combat victory in history and amass an extraordinary record as a fighter, fighter-bomber, and reconnaissance platform during the course of the Korean War. Afterwards, though outdated, it performed yeoman's duty with various Air Guard and Air Reserve units, being finally phased out of U.S. service during 1958. In total, including prototypes and production aircraft, some 1,732 P-80s were built. As just one of their several significant legacies, the XP-80 and the two XP-80As left behind the consummated reality of one of Kelly Johnson's long-held dreams, an experimental department where the designers and shop artisans could work together closely in development of airplanes without the delays and complications of intermediate departments to handle administration, purchasing, and all other support functions. He aspired strongly to have a direct relationship between the design engineer, the mechanic, and manufacturing, and he wanted a chance to prove it would work. The P-80 project provided that opportunity and served as the seed for what would grow into the world's most famous and mysterious aircraft manufacturing institution. In any retrospective describing the history of the Skunk Works, it is necessary to confront the period from 1945 to 1954 with some trepidation. By late 1945, the Skunk Works, as it then existed, had served its purpose and effectively had ceased to exist as a separate entity within the corporate umbrella of the Lockheed Aircraft Company. Regardless, Kelly Johnson had not let the success of the XP-80 program be absorbed by the ever-threatening corporate bureaucracy. Having seen the attributes of the unencumbered design and manufacturing system he and his Skunk Works teammates had created, he was determined to retain its operating philosophy for future endeavors. By the time the P-80 was handed off to Lockheed's Department 28-10 for expansion into a production program, several other aircraft had been brought on board under the Skunk Works operating philosophy for future execution. These projects, the prototypes for the Model 75 Saturn, the XR-60-1 Constitution, the T-33 and T2V-1 Sea-Star, the F-94 Starfire, the XF-90, the RB-69, the X-7, the R-7V2 YC-121F Constellation, the XVF-1, and the YC-130 Hercules would not all be brought to life at once under the Skunk Works umbrella, but rather would arrive with surprising regularity over a period of some 9 years. This steady workflow kept the Skunk Works alive philosophically, but did little to retain any coherent core group that could accurately refer to itself as the Skunk Works. Significantly, during this period, none of these aircraft would be created in a true Skunk Works atmosphere, but rather would utilize various aspects of the Skunk Works approach to prototyping. In every instance, some aspect of design, engineering, or construction was handled by what now is looked back upon simply as the vestiges of the old XP-80 approach. In many cases, the engineering talent was the same as that utilized for the XP-80. Only now it was operating under the aegis of Lockheed California Company, rather than independently under the aegis of the Skunk Works. Keeping it all alive was Kelly Johnson, who was, at times, the only physical manifestation of what remained of the original Skunk Works. Often working on several projects at once, he rarely distinguished between Lockheed aircraft being done in the Skunk Works and aircraft that were not. It was truly a unique period, and one that will forever remain a gray area in the advanced development project's history. Ben Rich, retired LADC president, today refers to it as the time of the Skunk Works Fast Action Shop. Its singular purpose was to create or assist in the development of prototypes quickly and quietly, and with minimal outside help or interference. Then we had our Saturn, a small transport airplane on which we made the most complete market survey we've made on anything up until recently, and it was to be a low-cost per airplane mile airplane. It was good, but it was a complete failure, because it faced 10,000 C-47s that were available at half the cost, and were better in terms of several other regards, larger mainly, and available quickly. Tony LeVere piloted the first flight on June 17, 1946. By late 1947, the handwriting was on the wall. The Saturn was not going to be a successful venture, and there was no reason for Lockheed to throw any more money into its development. In spite of its relatively low operating costs and its better maintenance characteristics, it could not compete against $25,000 Douglas C-47s and similarly cheap C-54s. Flyaway costs of the Saturn were now expected to be between $100,000 and $130,000. Taking advantage of tax write-off options, the two prototypes were released to reclamation crews to be chopped up as scrap. The Constitution was a Navy project, actually started out as a program for Pan American Airlines at 184,000 pounds gross weight. In this project, we used the Skunk Works engineering methods, but we used conventional shop practices. The aircraft was good, but we never got the 5,500 horsepower turboprop engines it was designed for. It ended up one of the world's most underpowered airplanes. The Lockheed R-6V Constitution was a large propeller-driven double-decker transport aircraft developed in the 1940s by Lockheed as a long-range, high-capacity transport and airliner for the U.S. Navy and Pan American Airways. Only two of the aircraft were ever built, both prototypes. Although these two planes went into service with the Navy, the Constitution design ultimately proved underpowered and too large for practical airline use at the time. Other studies using various Wright, Allison, and Pratt & Whitney engines also were offered, but to no avail. Finally, a turboprop version powered by British-built Armstrong-Siddeley Pythons was studied, but eventually rejected, as Lockheed Vice President Cyril Chapelet later would lament, "Even if we could have hung bigger engines on it, the Model 89 faced a dim future in the commercial market. Pan American, though seriously interested at first, reappraised its operations at the end of the war and decided the airplane was too big for immediate traffic needs. Although the Martin JRM Mars flying boat had a slightly longer wingspan, the Constitution remains the largest fixed-wing aircraft type ever operated by the U.S. Navy." From that came the T-33 and then a series of derivatives for interceptors. The T2V was a Navy program, a carrier-based airplane, and we made as many of those as the Navy had engines for. It was a success. The Lockheed T2V Sea-Star, later called the T-1 Sea-Star, is a carrier-capable jet trainer for the United States Navy that entered service in May 1957. Developed from the Lockheed T-33, itself derived from the Lockheed P-80 Shooting Star, it was powered by one Allison J-33 engine. Starting in 1949, the U.S. Navy used the Lockheed T-33 for land-based jet aircraft training. The T-33 was a derivative of the Lockheed P-80 F-80 fighter and was first named TO-2, then TV-2, in Navy service. However, the TV-2 was not suitable for operation from aircraft carriers. The persisting need for a carrier-compatible trainer led to a further, more advanced design development of the P-80 T-33 family, which came into being with the Lockheed designation L-245 and USN designation T-2V. Lockheed's demonstrator, L-245, first flew on December 16, 1953, and production deliveries to the U.S. Navy began in 1956. Some 5,691 T-33s of all kinds eventually were manufactured by Lockheed. An additional 656 aircraft were manufactured by Canada Air in Canada, and 210 aircraft were manufactured by Kawasaki in Japan. Additionally, Well over 1,000 Lockheed-manufactured T-33s eventually found their way into the air forces of over 20 countries around the world, many under the aegis of the Mutual Defense Aid Program. In all, the Navy bought 150 T2V-1s, redesignated T-1A on September 18, 1962, before the Lockheed production program ended during 1959. At this time, right after World War II, there was a whole stable of prototype airplanes, starting with the F-87, F-88, F-90, F-91, and a bunch of bombers. We had lots of prototypes then. The Lockheed F-94 Starfire was a first-generation jet-powered all-weather day-night interceptor of the United States Air Force. A twin-seat craft, it was developed from the Lockheed T-33 Shooting Star trainer in the late 1940s. It reached operational service in May 1950, with Air Defense Command replacing the piston-engined North American F-82 Twin Mustang in the all-weather interceptor role. The F-94 was the first operational USAF fighter equipped with an afterburner and first jet-powered all-weather fighter to enter combat during the Korean War in January 1953. Although requiring much time and delaying the F-94C's entry into service by nearly 2 years, the various airframe, system, and power plant modifications and improvements resulted in the Air Force obtaining a potent interceptor. True, the F-94C was not as fast at high altitudes as other all-weather fighters then being procured by the Air Force, but at low altitudes it was the best of the lot. Furthermore, once modifications eliminated engine flameout when all 24 rockets were salvoed, the closed breech installation of its armament rendered the Starfire substantially more accurate than the F-86D and F-89D, which had open-ended rocket installations. In the end, its limited range was the aircraft's major shortcoming. This, however, was not due to a design oversight, being the ultimate development of a relatively small 1943 design. The F-94C did not have the internal volume required for greater fuel capacity. The first 9 production F-94Cs were accepted by the Air Force during fiscal year 1952. The last 225 Starfires were accepted during fiscal year 1954. Eventually, the F-94C went on to have a lengthy and modestly successful Air Force service life. The XF-90 was the only airplane to defeat the atom bomb. Its military requirement concept was poor, and it was 10 years before the engine for which it was designed was available. It didn't come out good. The Lockheed XF-90 was built in response to a United States Air Force requirement for a long-range penetration fighter and bomber escort. The same requirement produced the McDonnell XF-88 Voodoo. Lockheed received a contract for 2 prototype XP-90s, redesignated XF-90 in 1948. 2 prototypes were built, serial number 46-687 and 688. Developmental and political difficulties delayed the first flight until June 3, 1949, with Chief Test Pilot Tony LeVere at the controls. On August 28th, Johnson noted, "Took a trip to Wright Field in Washington again. The picture is extremely confused. I'm sure we could build our prototype 90 ground attack airplane if we wished, but information which we have collected on the Russian airplanes plus the long delay that would now result before getting into production makes the 90 obsolete. I cannot recommend building it to face airplanes 4 and 5 years from now that will have 15 degrees more sweep, half the weight, and 1/3 the range. Couldn't stand that. Have recommended we drop the airplane in a memo to Hall and Bob on September 5th. A final note on September 6th stated, "Dissolved 90 project permanently." On September 11, 1950, the McDonnell XF-88 was declared the competition winner. In truth, the XF-90 had been marked for failure from birth. With an ill-defined Air Force specification, a weight problem stemming from an attempt to meet a poorly understood mission requirement, and power plants that could not possibly compensate for the excessive structural overkill, the XF-90's operational prospects were virtually non-existent. On the positive side, Lockheed and the various Skunk Works engineers who conceived and built the XF-90 pioneered the use of 75 ST aluminum, some 25% stronger than the commonly used 24 ST aluminum, verified the viability of the unusual horizontal tail, vertical tail structural control system mix, and indirectly participated in the improvement of the jet engine afterburner. Late in the program, when refitted with the afterburning Westinghouse XJ34-WE-15 engines, both prototypes showed improved performance, but not enough to overcome that of their primary competitor, the McDonnell XF-88. Though none of the penetration fighter contenders would enter production on their own merits, the developed XF-88 in the form of the F-101 Voodoo would eventually have a long and eventful Air Force career. As to how, according to Johnson, the XF-90 defeated the atom bomb, suffice it to say the second aircraft still exists. Used as a test specimen during the 1952 atomic bomb tests at Frenchman's Flat, Nevada, it survived 3 massive blasts with remarkably little damage. Recent interest in recovering it for the museum display has been discouraged, primarily because it remains highly radioactive. The first XF-90 was sent to the NACA's laboratory in Cleveland, Ohio, and there used as an exemplary structural test specimen. Its final disposition is unknown. XF-90 research, development, test, and evaluation costs totaled at $5.1 million. The estimated unit price for the first 170 production F-90s was estimated to be $670,000. Kelly Johnson lamented that price was as much as the early Constellations. X-7 was a Ramjet test vehicle. Made a good many of those things. It was designed to fly at speeds up to Mach 4.0 at over 93,000 feet altitude. It tested the engine for the Beaumark. It was an engine test research vehicle. Post-war analysis of available technology and the attempted assimilation of the massive quantity of data accessed as a result of Nazi Germany's capitulation found the U.S. aerospace industry in an envious but extraordinarily complicated position. The sheer mass of data suddenly laid at the feet of U.S. academicians and technocrats during 1946, coupled with the opportunity for research into virtually every facet of the aerospace sciences, at times proved overwhelming. There seemed to be no limits. Though funding was always an issue of significant contention, the post-World War II perspective on military spending for research seemed to be one of blind benevolence. And, as a result, many obscure programs were given what amounted to blank checks. Though not necessarily falling into the latter category, propulsion system projects created to explore virtually every form of jet, rocket, turboprop, reciprocating, and ramjet power surfaced in overwhelming numbers. Strong military support for these myriad undertakings brought many of them to fruition, including a significant number optimized to explore the attributes of power plants for supersonic aircraft. This was particularly significant in light of the fact the first supersonic flight, on October 14, 1947, had yet to take place. The X-7 was called into production by the United States Air Force, requirement for the development of an unmanned ramjet test plane with a top speed of at least Mach 3. The X-7 project was developed under the AMC designator MX-883 and was given in the Lockheed in-house designation L-1011. The L-1011 was initially designated the P2V by the USAF, but was later designated the X-7 in 1951. Despite its first launch being a failure, after redevelopment of the original Ramjet following test flights were successful. During the 130 X-7 flights eventually logged, many test items and projects were parasited onto the basic vehicle. A few of these included the modification of one X-7's wing to accommodate no less than 300 thermocouples to record temperature data and the experimental use of H2O2 fuel additives and boron-based high-energy fuel. The latter was tested on 3 different occasions. Though the results were favorable, the logistics of handling the extremely toxic propellant proved formidable. Besides being dangerous to inhale, even in minute quantities, it also was hypergolic. The X-7A1 and X-7A3 series were followed by 5 X-7Bs, intended to test guidance and control systems in the same way the X-7A tested power plants. The X-7B program was terminated just as the flight test program was getting underway. 12 X-7B flights were completed prior to cancellation. A relatively unmodified version of the X-7A3, known as the XQ-5 and given the name Kingfisher, was developed for use as a dedicated high-speed target drone. Somewhat surprisingly, the XQ-5's performance proved significantly higher than that of the surface-to-air weapons it was designed to test, and it is doubtful that any were destroyed by enemy action. This situation eventually affected the XQ-5's operational career as a Bomark and Nike anti-aircraft missile systems target, as it literally performed its way out of a job. Approximately 80 of the 130-plus X-7 XQ-5 flights attempted were successful, either partially or completely. Problems of bewildering variety surfaced during the course of the flight test program, including range safety concerns, ineffective radar control, malfunctioning autopilots, simple human error, and poor design. But the missile's enviable performance envelope eventually became an item of considerable pride for Lockheed's fledgling missiles and space company. Our first Navy program was next, the XFV-1, a tail-sitting airplane for direct takeoff and landing from a small area on any Navy ship. It was supposed to back down onto the deck. We did excellent in terms of cost and weight, but this aircraft was a failure. It was a failure because we had a bad power plant, and we couldn't look back over our shoulder when flying the thing and judge height. We could practice on clouds all day, but this is the only airplane we ever built, which we were afraid to fly ourselves in the final tests. During 1947, the Air Force and Navy initiated feasibility studies calling for the design and development of several different vertical takeoff and landing aircraft types, including fighters. The Navy in particular found VTOL appealing primarily because of the inherent deck space limitations and the associated shortcomings of steam catapult and arresting gear systems utilized on most then extant aircraft carriers. During early 1953, the first XFV-1 was completed at Lockheed's Burbank facility with an interim 5,850 equivalent shaft horsepower XT-40A6 engine in place of the more powerful YT-40A14 scheduled for actual flight tests. Lockheed test pilot Herman Fish Salmon was assigned to the aircraft as chief test pilot on December 23, 1953, during the course of a high-speed taxi test at Edwards Air Force Base. The aircraft inadvertently became airborne for the first time. Salmon landed moments after leaving the ground. A review of the program's progress now indicated a continuous inability to sustain flight operations sufficiently to retain pilot experience as a result of repeated delays for major component breakdowns. Therefore, since the installation of the engine and propeller did not show the high degree of reliability required, the XFV-1 program was terminated. And there was the Navy version, R-7V2, We had poor performance in the Skunk Works there, because we'd tangled with 17-7 stainless steel, which required 1 million parts in very thin gauges that were very difficult to assemble. We had to do them over twice, and this was a failure. It was a failure, even in the experimental phase, because of the high cost. The airplane flew good and all that, but never went into production. On August 18, 1950, the United States Navy signed a contract for 11 military transport versions of the Lockheed L-1049. The aircraft were to have been convertible troop cargo transports, based on the model L-1049B. The R-70-1 would have also featured round portholes in place of the rectangular ones on Air Force C-121C Constellations. The aircraft entered evaluation service in the Navy's oldest test squadron, VX-1, based in Patuxent River, Maryland. In November 1951, an idea came about to build a turbine-powered version of the R-70-1. This new aircraft was designated L-1249A by Lockheed. In 1954, two R-70-1s, then designated R-7V-1, were pulled off the assembly line for conversion into prototypes for the new L-1249A. The landing gear was strengthened along with the fuselage and wings of the aircraft. Extra fuel tanks were also added on the wingtips of the two aircraft, increasing the fuel capacity to 7,360 gallons. The wings were also shortened from 123 feet to 117 feet 7 inches. The new aircraft was designated R-7V-2 and first flew on September 1, 1954. The R-7V-2 reached 412 miles per hour, making it the fastest transport aircraft in the world at the time. The two R-7V-2 aircraft were delivered to the Navy on September 10th the same year. In 1953, the United States Air Force became interested in the L-1249A project. Two R-7V-1 aircraft were again taken off the production lines in 1955 and converted to L-1249A standards. These aircraft, designated YC-121F, were identical to the R-7V-2s in service with the Navy. The first YC-121F flew on April 5, 1955, and was delivered to the Air Force in July 1955. The aircraft were put into service with the test squadron of the 1700th Air Transport Group of the Military Air Transport Service, based at Kelly Air Force Base, Texas. After undergoing brief testing, the YC-121F was used on regular basis transportation flights. On one occasion, Lockheed test pilot Roy Wimmer managed to reach a top speed of 479 miles per hour in the YC-121F during a 20-degree dive. On January 25, 1957, a new transcontinental record for propeller aircraft was set by YC-121F, which flew from Long Beach to Andrews Air Force Base, Maryland, in 4 hours and 43 minutes. Lockheed proposed an airliner version of the L-1249A designated L-1249B. This would have had the fuselage of the L-1049E and be equipped with extra fuel tanks on the wingtips, as well as 4 5,500 HP Pratt & Whitney PT-2F1 turboprops. In the end, airlines were still in favor of the piston-engine airliners, so no L-1249B was ever constructed. After completion of their respective flight test programs, the 4 turboprop constellations were dismantled and their parts utilized to keep other constellations in flyable condition. Though modestly successful, the turboprop constellation program proved too little, too late. The jet age by the mid-1950s had filtered down to the airline industry, and with the advent of the de Havilland Comet, the Tupolev Tu-104, and the Boeing 707, it was apparent the future lay in pure jet airliners. Turboprops continued as viable engine options for smaller, short-legged commuter aircraft, but their use on transcontinental and intercontinental airliners proved economically unjustifiable. One of the least known of the Skunk Works' many efforts, the RB-69 program was initiated under the aegis of a CIA contract calling for an aircraft to monitor and document electromagnetic emissions and transmissions in denied territories. The project was begun during 1954 with Kelly Johnson overseeing program manager Luther McDonald, who effectively ran it until 1957, when Fred Kavanaugh took over after being pulled from the P2V program. McDonald, in order to meet the CIA's mission profile, had proposed the use of Lockheed's venerable P2V Neptune, then the longest-ranged twin-engine aircraft in the world. Under the auspices of a Skunk Works-type engineering and manufacturing environment, 5 new P2V-7s and 2 older Navy P2V-7s became RB-69s and were secretly rolled out at Burbank with Air Force markings during 1955. Delivery flights were made to Edwards AFB North Base, where flight testing was accomplished in considerable secrecy. Referred to by the CIA as Project Cherry, or later Wild Cherry, the objective was to build an aircraft that could safely penetrate denied airspace, gather intelligence data, and return, all without being easily detected by defensive systems. U.S. pilots hired by the CIA to fly the RB-69, like their U-2 counterparts to follow, went through a sheep-dipping exercise that effectively erased their real identities and replaced them with backgrounds that were totally fictitious, right down to their contrived names. Each aircraft carried a crew of 12, including a pilot, a co-pilot, a flight engineer, a radio operator, and 8 electronic intelligence personnel to operate the various sensor systems. A mix of penetration and border surveillance flights were flown. One of the first objectives was the collection of power grid data. This was acquired by flying over Western Russia's power lines. When the European operation was compromised by a U.S. officer, he reportedly was entrapped by a female KGB agent. The Wiesbaden missions were terminated. Chinese operations then became highest priority. The Chinese operation began during early 1957 and continued for the following 7 years. The Chinese, frustrated by the RB-69's unfettered night penetrations of Chinese airspace, eventually perfected a night illumination system that successfully exposed the aircraft long enough for fighters to make visual identification and attack. These required that large numbers of Ilyushin Tu-28s and Shenyang J-5s be sent aloft to drop flares. These lit the entire night sky, and in so doing exposed the RB-69s and permitted their interception and destruction. The successes thus realized proved instrumental in the 1964 CIA and Taiwanese decision to remove the type from operational service. Then comes the YC-130. The first 2 prototypes were built using partial Skunk Works methods. It was then taken and moved down to Georgia, who took it on and went into production. That is now heading for a total of 1,500 airplanes. I think the concept was good. It demonstrated our ability to hand it off to another production organization who took it and made it work. On February 2, 1951, the Air Force Tactical Air Command issued requests for proposals to the Boeing, Douglas, Fairchild, and Lockheed aircraft companies, calling for a medium-weight turboprop-powered transport capable of meeting the specifications and performance criteria outlined in any one of 3 general operational requirements it included. The Air Force demanded a quick response to the RFP, and within days of its release, Art Flock had been assigned as Chief Project Engineer with Willis Hawkins as General Supervisor. Hawkins, at the time, was also in charge of Lockheed's preliminary design department. Skunk Works operating procedures would be utilized as appropriate to expedite design and prototype development. Working with Hawkins were Eugene Frost, Eldon Peterman, Dick Pulver, and Flock, all veterans of earlier Skunk Work projects under Johnson's guidance. Assigned the temporary design number L-206 and later becoming the Model 82, the new transport rapidly evolved under Flock's direction. As its configuration matured, so grew the preliminary design group's conviction it was creating a logical yet utilitarian aircraft capable not only of achieving but superseding the basic GOR objectives, specified payload range requirements 8 times that of any then extant design. During the course of design development and mock-up construction, inputs from external sources was invited and reviewed. Air Force and transport personnel were brought in from virtually every segment of the industry. Each was asked to critique the new aircraft and recommend changes or improvements. The resulting information was carefully assessed by Flock and his team and, where appropriate, incorporated into the actual aircraft. Additionally, Lockheed representatives associated with the Model 82's development visited facilities that could provide insight into operational requirements and usage. Interestingly, by this stage of the Model 82's development, Johnson had begun to have doubts about its ability to succeed. Unhappy with its rather proletarian aesthetic qualities, he had reached a point where he refused to sign off the paper proposals being submitted to the Air Force, forcing his boss company, Vice President Hal Hibbard, to overrule him. Because of Korean War pressures, the Boeing, Douglas, Fairchild, and Lockheed proposals were quickly evaluated by the Air Force. On July 2nd, 5 months after first receiving the RFP, Lockheed was informed its proposal had been picked for prototyping over those of the competition. On July 11th, contract AF-33 038-30453 was awarded Lockheed, calling for the construction and flight testing of 2 Lockheed Model 82s, formerly designated C-130 by the Air Force. In short order, the company officially named the new transport Hercules, in concert with its tradition of naming aircraft after stars and constellations. Accordingly, on August 23, 1954, with Stanley Belts as pilot, Roy Wimmer as co-pilot, Jack Reel as flight test engineer, and Dick Stanton as flight engineer, it departed the Burbank Airport at 2:45 p.m. on its first flight. Due in part to the fact the basic mission weight of 108,000 pounds had been 5,000 pounds lighter than guaranteed, cruising speed was some 20% higher. Takeoff distances were some 25% lower. Ceiling and initial climb rates were some 35% higher. Landing distances were some 40% shorter. And single-engine out-climb rates were a stunning 55% higher than predicted. Some 37 years after the first flight of the production aircraft, on May 15, 1992, Lockheed delivered the 2000th production Hercules, a C-130H, to the Air Force. This transport, representing one of the most successful aircraft production programs ever, is only the most recent heir to a legacy that now lays claim to a seemingly endless list of accomplishments.
They came up with a requirement for a tactical transport that had some very unique demands, such as a drive-on, drive-off capability on the airplane, which required the whole aft end of an airplane to open up, and numerous other unique requirements. And many people who saw the design, including the renowned Kelly Johnson, commented that it was the ugliest airplane he had ever seen.
In the late 1980s, the management of Lockheed Corporation reached a decision to vacate the huge factory complex at Burbank, where aircraft had been built for over 60 years. The time had come to move the aircraft work to more modern facilities elsewhere. By 1990, people and equipment were gone from many obsolete buildings that had covered more than 300 acres. These included the structures where, in 1928, Allen Lockheed and a small group of employees began making wooden airplanes in buildings once occupied by makers of china and glassware. It was on this site, 4 years later, that the current Lockheed Corporation was born. Lockheed's announcement that most of the buildings would soon be torn down stirred memories among many who had known the company in its early years. One of them was Harvey Kristen, who had joined the company soon after it moved to Burbank from Hollywood. As a teenage student from Pasadena, Kristen took a temporary job at Lockheed in 1928 and stayed on for nearly half a century until his retirement in 1974. Working in many branches of the company, Kristen was an eyewitness to events that took the firm from a fledgling in Burbank to a giant of the aerospace industry.
This is where it all began, our first day at work at Lockheed. To my rear was San Fernando Road and Empire Avenue. To my right, the Mission Glass Company. To the left, the China factory. Behind this venerable brick wall, the China Company had become a very important part of the Lockheed complex, utilized for fabrication and subassembly.
When Kristen joined Lockheed Aircraft Company, it had only 80 employees, some working in this building that had belonged to the Empire China Company.
They were building the Vega, wing monoplanes made of Sitka spruce, and almost in its entirety. Well, since the fuselage, the empennage, the wing, everything but the landing gear and the power plant were made of Sitka spruce, we used principally highly qualified cabinet makers. These men were extremely proficient in following layout drawings, engineering drawings precisely. They made temporary tooling of wood to make ribs, to form the airfoil of the wing. They had a mold that made the diaphragms, the bulkheads, which, by the way, were made of almost 20 to 30 laminations of Sitka spruce. And I must add that at this point, and this is important, a piece of Sitka spruce, 1/4 by 3/4 by 24 inch long, 8 annular growth rings to the inch, free of all rosin or leaks, hold 24,000 psi, laminated into a bulkhead. It pulled 120,000 psi, which is the equivalent of some pretty high-grade chromolybdenum steel. Didn't know that at the time, but we found out later that spruce airplane had the qualities and the strengths of many, many metals, but had the flexibility of a spruce tree.
Leading the small group of airplane builders was a man whose name would become famous in the industry, Allen Lockheed.
Allen and his brothers, Malcolm and Victor, were in on the original group with their chief designer, a man, well-known man, Jack Northrop, who was the outstanding creator of the monocoque fuselage and the type of airplane that the Lockheed Vega and other models turned out to be. A man named Tony Stadelman, who came from Czechoslovakia by way of the Middle West, turned out to be the factory man, the builder, the man who could take all of Northrop's designs and create them into an airplane. These men I just mentioned were the principals of the Lockheed Company that came to Burbank.
Production of the Vega and other wooden aircraft at Burbank was threatened in 1929 when the American economy went into a tailspin.
And the Lockheed Company was struggling to maintain its workforce and its capacity, which was minimal. And Alan Lockheed was approached by a group from Detroit who formed Detroit Aircraft, who had hoped someday to become the General Motors of the Air, and Lockheed was one of their acquisitions, along with Ryan Aircraft, Parks Air College, and Evans Pump Company, etc. But they no more than established themselves as the new owners of Detroit Aircraft, bringing their executives to our company. And along came a very, very, very difficult time known as the Depression, the Great Depression. So Detroit Aircraft found themselves overextended financially, and they went into bankruptcy. And coincident to that, a far-sighted individual who was a Detroit Aircraft executive and general manager of this plant representative named Carl B. Squire, worked with local people through the Title Insurance Trust Company, and were able to put the Lockheed Company into receivership under California law, prohibiting then the company to be sold off piecemeal and disappear as a name, as an asset of the Detroit Aircraft Company. There were only 3 people in the entire company during the Title Insurance Trust Company and California receivership. Carl B. Squire, who stayed here from the Detroit organization as general manager for them, became the head man of representing the receivers. A chap named Ronald King was the bookkeeper, and a fellow named Harv Kristen was the factory man, handling minor repairs, shipping spare parts, providing spare parts, bringing in crews as necessary by Mr. Squire's orders and the customer's agreement to do major repairs. We kept the plant open on an on-call basis, and we paid, by the way, not by checks, but by cash envelopes, by the hour, by the job. In June of 1932, a small group of investors headed by Robert Gross, including Cyril Chapelet, Carl Squire, Mr. Ryan and Larry Ames, and Walter Varney of the Varney Speed Line, were able to put together $40,000, which seemed to be an appropriate bid at the time for the company. There were others that attempted to consolidate and be bidders, but did not quite make it. Therefore, on the day of the court sale, Mr. Carl Squire, who was going to represent those of us that were at the factory, suggested that I might go down and witness the sale. We took the Lockheed truck. I took the Lockheed truck. We drove down, sat in the rear of the courtroom very inconspicuously, and observed the following. When Robert Gross presented the $40,000 check to the judge turned to him before closing the sale and said, "Young man, I hope you know what you're doing." And Mr. Robert Gross said, "Yes, sir," most enthusiastically. And with that, the judge hit the gavel on the desk, and sold was his statement. And that concluded the sale out of receivership, but the beginning of our wonderful company that we have today. You know, there was an era in the aviation world when it took a Lockheed to beat a Lockheed. And when better airplanes were built, we said, Lockheed will build them. And that's when the Vega brought the good name Lockheed into the limelight as the most reliable, best performing, highest cruising speed, best fuel consumption airplane flying in its day. Famous pilots, Wally Post, who flew around the world on 2 occasions, once with a navigator and once alone, and then broke the record for high altitude performance with a flying suit of its day, the forerunner of today's astronaut suits, by making a little red Vega that normally cruised at 150 miles an hour, cruise at 350 from our Southern California to the East Coast. Other than Wiley, there were famous pilots such as Roscoe Turner, who flew for Gilmore L Company. He was a flamboyant type of a pilot, but he brought great credit to our airplanes. both the Vega and the Air Express, which became the Earl Gilmore Oil Company airplane, where he, as his mascot, carried the lion, Gilmore. Other pilots, such as Sir Charles Kingsford Smith, who flew the Pacific in a Lockheed L-1011. And then there was the Magyar brothers, who flew the Justice for Hungary from New York to Budapest, bringing to the attention of the world the freedom for Hungary. Well, Jimmy Doolittle came to us as a bit of a hero because he had made the first flying landing in Dayton, Ohio under a hood. Had never been done before. Complete landing without sight of the terra firma. When Jimmy Doolittle acquired his Lockheed Orion, a derivative of the old original Vega design, he was the research pilot for the Shell Oil Company. By 1934, the company had made the management decision to proceed with this new Electra Model 10. And it was built assembled primarily in the hangars that were left here by the old original Lockheed Detroit Aircraft Company. Final assembly, if you please, outside of the hangars, because the hangars were not big enough to take on the wings of the airplane and the assembly. From there, they proceeded to our own little flight line along this railroad strip, not yet anything but a dirt runway. And from there, the initial Electra flew and was tested and accepted by our then chief test pilot, Marshall Heedle, and a pilot on loan from the Boeing Company. The reports on this new twin-engine, all-metal version of the Lockheed airplane began to come back from Michigan, recommending the abandonment of the single fin and rudder and the adding of the double tail, the twin fins and rudders, for directional stability, for single-engine outperformance. And that was accepted on the spot. And as a result of that decision, that became the hallmark of the Model 10 Electra, this double tail. And it was recommended by none other than Clarence L. Johnson, who very shortly became the chief aerodynamics of our present company. During the 1930s, some very interesting and famous pilots came by to evaluate our Electra because of its very, very high performance characteristics, and especially its single-engine performance and its long range. Amelia Earhart was another one of those famous and wonderful persons that we got so well acquainted with, because when Amelia came to acquire her first little red Vega, as she called it, she put on a pair of Lockheed coveralls and went out in the shop and worked next to the woodworkers and the cabinet makers and then the final assembly, and went out on the flight line as part of the crew, and was a most gracious lady and a most appreciative lady, because she knew when she flew her airplane, almost every nut and bolt of any importance as it was assembled, her confidence factor was improved immensely by the fact that she was a part of the building of her little red Vega. And naturally, we were so proud of her because she flew the Atlantic alone and was quickly named Lady Lindy. When she flew the Atlantic, she, of course, landed in Londonderry, Ireland. And the people, of course, that were most gracious and most appreciative of her wonderful accomplishment. Later on, in years to come, we had another great experience with Amelia when she came out to personally become involved, just as she did on the Vega with her Model 10E Electra, that it was very specially built for her because she was going to carry approximately 1,100 gallons of fuel. She was going to have special navigation equipment. And in the process of building her airplane, once again, she put on coveralls and became especially involved in what we called our QEC, our power plant installations. In fact, I can recall her help plumbing and the engine installation, because she wanted to know firsthand how and where the fuel, the electrical power, everything came from in the power of the airplane, knowing full well that with two engines, she'd need them both with the heavy load takeoff that she was about to make on the round-the-world flight. In other words, once again, Amelia became part of our crew, part of us, in the process of building an airplane. Another demonstration of a great pioneer and a wonderful lady. Then there was Charles Lindbergh and his wife Anne, who frequented our place daily almost during the process of the building of their Cirrus. We built it, of course, as a fixed gear land plane, but knowing in the final analysis that he was going to do a route survey of the Pacific for Pan American, but that Cirrus that he and Morrill Lindbergh acquired was very special, because we put a canopy on, we put things on to protect them from the elements, because Anne became his navigator and his radio operator. Just think of it. Here's a lady that just never had an experience like that until she married this wonderful pilot, this wonderful fellow, Slim Lindbergh. They eventually, of course, put floats on the airplane. And testing that airplane, which we'd never put floats on before, was quite a unique experience. Again, the center of gravity, fuel loading, and the takeoff characteristics of a seaplane, so different than a land plane, caused us to go through some very interesting, we call them high taxis. And of course, to get a float up on the step, you almost have to have a turbulent sea. A smooth sea gets you nowhere. Lindbergh knew that. And they used to go ahead of him when he tested with a high-speed boat to create the turbulence in the waves and the water in the wake of the boat to help him get the vacuum broken under the steps of his floats. What an experience it was for us, because we had never built a low-wing Cirrus seaplane before. Yet another wonderful experience was to have this great pioneer, most enthusiastic aviation man named Howard Hughes come to our plant with a little Boeing P-12 and ask Kelly Johnson and our engineers and Mr. Gross if we could modify it and turn it into a high-speed racer. It turned out that it was my good fortune to be in charge of that project. And we had a no-holds-bar latitude. We could get anything anywhere we wanted at any time. We stripped the fabric down to the bare tubular skeleton. And with a little skill and special engineering, we were able to make it into a monocoque-type shaped fuselage with sheet metal, streamline it, put streamlined gear, landing gear on, add a terrifically heavy-duty, high-powered power plant, compensate the center of gravity for Howard. And we accomplished that in weeks, not months. And following that, we had the great experience of Howard selecting the Super Electra, we call it the Model 14, to fly around the world. And of course, that took special handling with regard to fuel consumption, fuel capacity, navigation gear, navigation equipment. And in 14 days plus, I believe it was, he made the round-the-world flight and very successfully demonstrated that transport equipment, commercial transport equipment, was able to make some of these extended hops under controlled conditions.
In the 1930s, before Lockheed had any facilities at the nearby commercial airport in Burbank, the company did all of its flying from a dirt runway between Empire Avenue and the railroad tracks.
This is the site of the original 2,000-foot dirt runway. gopher holes and all. It's from this very runway that the famous Winnie Mae of Wally Post, Amelia Earhart's Little Red Vega, Sir Charles Kingsford Smith's Altair, Lindbergh's Cirrus, all of them flew from this very runway.
In the late 30s, war broke out in Europe. The British had an urgent need for new aircraft. Lockheed offered to build a new bomber.
During that period, we had expanded the design of the Electra into what we called the Model 14, which was an enlarged semi-mid-wing version of a twin-engine, two-tail airplane. And at that particular time, the British were interested in getting support in the form of a patrol airplane to protect the coast of all of the British Isles. They came to the United States and reviewed the designs of our aircraft and others, competitors. They chose the Model 14, which we, in a 24-hour period under Kelly Johnson's supervision, converted into a mock-up of a Hudson bomber. And this is the very, very important area of the original Lockheed as we know it today. This is where Robert Gross's executives presided in their offices we knew as Mahogany Row. Also, this very spot, and through a switchboard right up in that corner, came the word from London, England, from Cortlandt Gross to Robert and his team that the Hudson bomber contract, up to that time the largest contract ever given to anyone in these United States, was consummated. When we received that order, immediately we had a procurement program established that was second to none, with the organizations such as the Aluminum Company of America and the engine manufacturers, because 200 Hudson bombers in one initial order never had come to any company in that quantity before, on a schedule that was so uniquely developed to meet British requirements. And the next requirement became, where are we going to build all these airplanes? So the company could only expand in one direction because Burbank was on the east, and that was it. So westward we came. We closed off a street called Lincoln Avenue and moved all the way up to Buena Vista, which is a offshoot of San Fernando Road and Turkey Crossing, where the little plant first started. As production accelerated and we were beginning to accumulate airplanes in our test area, and by the way, our test strip was the old dirt runway at B1. We did not have a paved runway, no lights, no traffic control. We were the traffic control by way of the pilot house, as we called it, right at the edge of that little runway at Burbank. And that's where the Hudson started his first testing, his first flying. You know, during the midpoint, or as we became quite well established on our Hudson line, along come a design competition that Kelly Johnson entered for Lockheed. Turned out that it became Lightning, the twin-tailed P-38. So what we did is we divided the assembly line into a Hudson line and a P-38 line, and started the P-38 line down through the same general overall assembly building, paralleling the Hudson bomber. The rate of the P-38 was slow and accelerating initially, but we got it up to where many P-38s a day came off that line, even faster production schedule than the Hudson. The P-38 program probably accelerated faster than any line in the area. We got to a point where we were able to roll a P-38 in an hour, but we had control over the condition of those airplanes to the extent that you could pick any airplane and decide what the status was and bring it up to flight status immediately upon receipt of whatever the requirements were that were missing in the assembly line. We had absolute control. The result was very few run-up failures or test flight failures. We had quality control by pride of workmanship and by a group of people who knew by experience on the Hudson line how to handle the accelerated program on the P-38. So the Hudson program became a very, very invaluable or valuable program for developing our skills to take on a dual assembly line at the time. The Hudson and the P-38 required no end of additional skills in piloting our airplanes, and we brought in some very, very famous people who maybe at the time were not, but became so important to the Air Force and to ourselves. To name but a few, Milo Burcham, who had flown with a group in a Boeing P-12 at air shows and had the skills that came with aerobatics and acrobatics and knew how to recover an airplane from test flighting conditions that you deliberately put the airplane through. So Milo became a very key figure. When Tony LeBeer came on board, little did we know that he was to bring that very unique skill. To Tony, the impossible was just a little more difficult. Tony was able to do things with the P-38, as was his partner, Fish Salmon, who became famous also. They literally flew test flights, monitoring each other, confirming each other's results, which was a rather unique condition. Tony would take a P-38 up and ring it out, go into a flat spin, do the impossible recoveries to satisfy Kelly, to confirm that not just one man could do it. Fish Salmon would go up and repeat the performance. All the while, Milo, who was chief pilot at the time, was biting his fingernails, hoping these two fellows didn't tangle, because sometimes they'd go up and literally do what we used to call combat-type maneuvers with each other. Right about the time that the P-38 and Hudson were going full swing, there was a need for second sources of some very prominent and very important airplanes, and one of them was the B-17. So all of a sudden, there became a subsidiary that had already started in the old China factory at what we call the old Lockheed Company as a design group with Max Short and a few important people that came from the Stearman Company. This fully owned subsidiary was known as the Vega Company, very proudly, because the Vega, in its early days, as you know, made the name Lockheed quite famous. So as the Vega Company came into being as the second source for the B-17 program designed by the Boeing Company, it became the number one second source, the other source being Tulsa, Oklahoma, run by the Douglas Company. The Vega Company built the facility around the assembly lines as they developed and the fabrication shops developed, expanded as the airplanes were being built and assembled, literally built the buildings over the workforce. This excellent facility of its day, built on the southeast corner of the airport, was to become the home of the Vega Company, a wholly owned subsidiary of Lockheed. One of the unique things about the Vega Company was when the Boeing Company had a challenge that would come from the Air Force to modify a B-17, the request would go out to the two subsidiaries. The first chin turret to protect the nose of the gunner and the nose of the airplane and the crew was a Vega installation. And I remember well going to the Long Beach staging area where we took our P-38s and Hudsons that were flown into the Pacific Theater, the Hudson to Australia, the P-38s into the General Kenny's work task force. That when a B-17 showed up at Long Beach with a chin turret on, you watched the ferry command they'd come out and walk up and down that line. And when they saw a chin turning on the airplane, that was their baby, because not a one had to be ditched in the drink. The Vega B-17 line, as we knew it, was built in the facilities adjacent to Hollywood Way, and literally in a facility that wrapped itself around the then Lockheed Air Terminal. And they successfully produced well over 2,000 B-17s on schedule to the latest Air Force requirements with a quality standard that made them second to none. You know, about that time, Pearl Harbor, you know, the scare of the submarine off of Galita, there was a scare that came across the entire West Coast. Shipbuilders, airplane builders, anybody that was vital to the defense program had to have the ultimate of protection. And somebody came up with the idea of camouflaging our plants. And, you know, this was quite an experience, because once again, all the trusses and all the cables and all the support structure had to be built over our heads as we were building airplanes. And the part that was so darn messy was the fact that they used chicken wire, as we called it, to stretch over these buttresses and cables and so forth over our plant. And then what did they do but blow feathers with an adhesive, waterproof adhesive, onto these wires? So we were picking chicken feathers out of our airplanes, out of our hair, all at the time we were building airplanes. But believe it or not, when we found out through aerial shots what our plant looked like from the air, we suddenly discovered we were a little community of houses and business buildings that somehow or other, the giveaway only that we detected was the fact that a railroad track ended and began in the middle of this little community that was called camouflage. Right in the middle of this intense production program, our great Kelly came up with another dream, because suddenly there'd become available in England an engine designed by a Mr. Whittle. It was called the Whittle turbine. And while that was going on, Kelly had already designed on paper how he was going to apply that little engine and that thrust to an airplane. That airplane became known as Lulabelle. It was built in tents. It was built in little buildings that suddenly became vacated and available, and then became secured and fenced off. And suddenly out of that little complex came drawings. We who were building the production airplanes suddenly became aware of a drawing that would come out for a forging and a part that had a peculiar name, like McCormick Deering Tractor, had no relationship to an airplane, to keep the design secretive. And when that went out to a forging company or whoever it was that made that component, they were put in a position of not needing to know. And that was the key. Unless you had a need to know, you didn't ask questions, you didn't become involved. So as Kelly built Lulabelle in a record 143 days, towed it up to then Muroc Dry Lake, now Edwards Air Force Base. And again, here comes that wonderful guy, Milo Burcham, who was elected to make the first flight in Lulabelle. Lulabelle flew, was very successful. The thing that Milo said, gosh, it maneuvers well, it's fast, and it gives you a feeling of confidence.
The flight of the XP-80 in 1944 launched Lockheed into the jet age. This design would evolve into America's first production jet fighter, the Air Force Shooting Star. While the first flights were being made, a new building was under construction on Empire Avenue, where the Skunk Works team would begin production of P-80s.
This is the famous cotton shed, built and patterned after the cotton bale storage places of the South. It was where the YP-80s were built, which were the forerunner of the production version, the P-80 Shooting Star. In the middle of the YP-80 project, there came a very special assignment. Secretively, we were to put slipper tanks out on the wingtips.
The wingtip fuel tanks gave the P-80 enough range for combat missions. The Burbank plant built over 1,000 P-80s. In the 1950s, they served in the Korean War and elsewhere around the world. Just before World War II, Lockheed had designed a large new transport. It was given a name that would become widely known.
The name Constellation became a famous name in our company, and we always named our airplanes after stars or constellations of stars. And the Cirrus was a star, the Vega was a star, the Altair was a star, and along comes the need for a bright and shiny new airplane that had the benefit of all those that had gone before, and it became a Constellation. And its nickname was the Connie. It was one of those unique experiences where a customer, naturally, in those days had to be found for their first group. Well, the customer turned out to be TWA, owned by none other than, at that time, our friend Howard Hughes. So as Kelly Johnson and his design staff and Robert and Corlin Gross and Howard Hughes would meet, they would draw and submit ideas of what the configuration should look like. Well, one interesting experience, and this is a factual experience. The first design that came up was a typical, very straightforward cigar-shaped fuselage. And it had a multiple tail, but it didn't look like what the Connie turned out to be. Mr. Gross looked at that airplane, as did Howard and the rest, and it was a very efficient-looking, straightforward design. Every section of that fuselage is identical. It was ideal for production. But Mr. Gross says that airplane doesn't look like it really wants to fly freely. Why don't we do this? He walked up to the blackboard, and he drew a couple lines that looked like a side view of a dolphin. And Kelly looked at that, and Howard looked at that, and they said, wow, if we do that, technically the fuselage becomes an airfoil because your shape is like the wing rib of an airplane wing. So all of a sudden, right then and there, in spite of the need for standardized production, we had a multiple shape design that, of course, made new bulkheads at every station and made it a little complex initially. But oh, how it contributed to the reputation of that airplane.
The first Constellations came off the Burbank assembly lines during World War II and served as military transports. At war's end, commercial airlines would begin ordering Constellations. Eventually, they would be in passenger service around the world.
To see it in the air was to see the most graceful airplane. And that Connie became the flagship of Pan American, Eastern Airlines, Chicago and Southern that became Delta, and many airlines in the European theater. Even Qantas Airlines down in the South Pacific, they put drop tanks, tip tanks on the wing, extended the range and made it look almost like a version of a military airplane, but it still had the grace of a Connie. And that airplane was, in a commercial sense, the airplane that took us into the next generation of Lockheed airplanes.
The military Constellation assembly line was one of many production lines that operated simultaneously at Burbank during World War II. Employment grew by the tens of thousands to meet wartime schedules.
The employment grew so fast, keeping head count was a near impossibility for us in the factory area. In fact, it wasn't our responsibility. We made the demand, the requirement. The personnel department brought them in and trained them. We certified them as being ready to go. We had a last word to say he's ready or send him back for a little more, give him a little more help. But in that process, all of a sudden, including our outlying plants as far away as Bakersfield, Beverly Hills, believe it or not, the old Ford motor plant called B2, the old Willys Overland plant in Maywood, where we made our drop tanks for our P-38s. All of those airplanes and all of those called for the maximum effort on personnel and training. At that point, we passed well over the 90,000 mark. In fact, some of our people will insist that we did reach the 100,000 mark. Conservatively speaking, I would say 90,000 plus. From a little company that, remember, started in 1928 with 80 people.
Many women joined the wartime workforce.
Yes, oh, the women came into Lockheed. They reached a peak of almost 40% of our production workforce. They particularly adapted well to precision work. Their fingers were more nimble. We were all thumbs. They could put an instrument panel together. They could assemble wiring bundles to install as a unit into the airplanes. They could assemble hydraulic units very precisely. They adapted so beautifully. And we brought that term out at the Vega company called Rosie the Riveter. But believe it or not, Rosie the Riveter was a symbol, but the riveting was one of many, many skills that they brought to our company.
During the war, the company's Burbank facilities had expanded to cover several hundred acres. Factory buildings spread for half a mile east and west of the old China Company quarters at Empire Avenue and San Fernando Road. A mile to the west, another factory complex had been created for B-17 and Constellation production. By 1945, the Burbank factories had built almost 19,000 combat aircraft for America and her allies. When the war was over, Lockheed continued production of Constellations in commercial airline as well as military versions. The company and its Vega subsidiary also began designing new aircraft, including one for the Navy's anti-submarine patrol missions. It was named the Neptune.
They wanted it to be compact, not cumbersome, small by comparison. So they come up with the idea that it would be a two-engine airplane with a tremendous fuel capacity to stay on station and yet have the ability to carry the payload that was required. And it had to have some unique features never before installed. For instance, it required a magnetometer that heretofore had been used in the oil industry to find and locate oil fields, which was a device that was attached to the airplane. It looked like a stinger. And so the P2V Neptune was the second breath, you might say, of the beginning of the very successful career of the Vega Airplane Company and its contribution to the services. And another version, Operation High Jump, South Pole Expedition. Suddenly, we got the request to develop a ski airplane. Well, it come out that it wasn't just one. It was a sequence of ski airplanes, backup airplanes, where the Navy was going to go to the South Pole and do some exploratory work. Another very important contribution that P2V was made to the Navy and to our services and to our country was the fact that it demonstrated that it had the ability to stay airborne for hours beyond any aircraft up to that point. To demonstrate that, a commander took an airplane and designated the truculent turtle. What a name for an airplane that performed like the P2V. He flew that airplane nonstop from Australia to Columbus, Ohio. And incidentally, when he landed, he played it safe. He had enough fuel on board. He could have gone to the Navy base in Washington, D.C.
During 16 years, starting in 1946, the Burbank plant built more than 1,000 Neptunes in many versions. The P-2 also was built by the Japanese under license from Lockheed. The factory buildings expanded in the 1940s to produce a variety of aircraft types, including one that would become the biggest airplane ever built in Burbank. Its assembly would require Lockheed's largest building in Burbank.
In the mid-1940s, Lockheed was fortunate enough to be contacted by the Navy to develop a heretofore never designed or built aircraft known as the Constitution. It required a very special hangar. We called it the Constitution hangar because it had to have a clearance for that fin on that Constitution of 6 stories. The cockpit, in fact, was 3 stories above the ground. This facility hereafter was known as the Constitution hangar.
Designed to take off at a maximum weight of 92 tons, the Constitution needed turbine engines. Because turbines were not yet available, the 2 prototypes began their test flying with piston engines of 3,000 horsepower each. The mission was to transport Navy personnel and their equipment, as well as a senior officer in an airborne command post.
Took the initial first number, serial number 1, to Patuxent River. And to the amazement of the Navy test pilots in the program down at Pax River, this airplane did things that no other airplane had ever done. And why? Because for the lack of the turbine engines, we installed JATO bottles integral to the wing. And we could take that airplane off the ground with the equivalent of 5 engines in power. Each of those JATO bottles developed 1,000 pounds of thrust for 14 seconds. And when you put 16 turbine valves, 8 on each side, 1,000 pounds each, suddenly you had 16,000 pounds of JATO thrust.
Lack of power kept the Constitution from full production, but the prototypes were forerunners of huge jet transports that would fly 20 years later. By the mid-1950s, turboprop engines were available. Lockheed began producing a new commercial airliner, the L-1011 Electra, using Allison T-56 engines.
It was a unique engine because it was a turboprop with a gearbox, but it had 2 speeds. It had a ground idle and it had a cruise. So our L-188, known as the Electra, and our C-130, known as Hercules, the Hercules being developed in the Skunk Works, almost parallel to the Electra, being developed in our production line. Of course, also demonstrated through our flight engineering group, which was closely tied to our Skunk Works operation because we were using the same power plants. we come up with this unique development where we could give to the airline commercially an airplane that could get in and out of facilities that no other, even reciprocating engine, in some instances, could handle, because of its unique ability to use maximum power with a constant speed engine. So the L-188 became a forerunner, of course, of the pure jet airplane, and airlines like American and Eastern flew that airplane and got maximum performance out of the airplane.
The arrival of the pure jets brought an end to Electra production after only 170 sales. But the basic design would soon lead to a new naval patrol aircraft that would remain in production for decades.
As the transition from turboprop to pure jets come along, and the Electra line had served its purpose during that transition period, we had an airframe, we had a hull, so to speak, that had many potentials. And we had a power plant that had obvious growth, and it became the Navy version of the L-180H, which is known as the P-3 Orion, or the P-3 ASW aircraft.
Lockheed built more than 500 P-3s at Burbank before production was moved to other facilities. The Orion became the principal maritime patrol aircraft of a dozen nations. At Burbank, new ideas led to additional designs that were built at other Lockheed facilities. The Skunk Works P-80 fighter evolved into a two-seat trainer, the T-33. Over 5,000 were built at Palmdale for air forces worldwide. In the 1950s, a need for a long-range, very high-altitude reconnaissance aircraft inspired Kelly Johnson and his team to design the U-2.
There was an airplane that had to be able to develop an ability to go out of the range of then known missiles, altitude-wise, and have a range, fuel consumption-wise, that was more extensive than even our long-range ASW-type airplanes that were designed for long range. So they come up with a unique airplane with a very slim glider-type, soaring glider-type wing, with a bicycle landing gear, a couple outriggers, a very reliable power plant, and a set of instrumentation that could sense and do a reconnaissance job that had never been done before.
Working closely with Johnson on the U-2 and later on other key programs was Ben Rich, who was to become head of the Skunk Works when Johnson retired. America's first Mach 2 fighter also emerged from the Skunk Works in the 50s. Over 700 starfighters were built at Palmdale, and 2,000 more were produced by foreign manufacturers. In Italy, production continued through the 1970s. By the early 60s, the huge Constitution hangar at the Burbank airport was shrouded in Skunk Works secrecy. Inside, a radically new aircraft was taking shape, fabricated mainly of titanium. Much later, it would be revealed to the world as the SR-71 Blackbird. In 26 years of service with the Air Force, SR-71s gathered reconnaissance data while flying over trouble spots at altitudes above 80,000 feet and speeds over 2,000 miles per hour. The Blackbird set world records for speed and altitude that designer Kelly Johnson predicted would be long-lasting.
I think it'll be a long, long time before we have an airplane that has higher performance than the SR-71, because the need for it is not there in terms of the fact that we can have satellites circling the Earth in 90 minutes, and we do not have to go any faster than what we go with this one right here, and it'd be very, very expensive to go Mach 4 or faster. So we may be seeing here the highest speed military airplane that there will be around for a long time.
In 1969, Lockheed received a Navy contract to develop a new anti-submarine patrol aircraft that would operate from carriers. Production soon began at Burbank.
Coincident to the production of the P-3, and as a parallel and a new development, came an onboard carrier type, a two-engine anti-submarine warfare airplane that had multiple missions even beyond the basic ASW as a tanker, as a support aircraft for the PS-3 fleet, which accompanied the carriers. That airplane is in operation today, and with modifications has been updated to concurrent requirements of the Navy and will be known as the first ASW-type Lockheed-built carrier airplane. In the 1970s, we came into the wide-bodied jet field with a high-capacity L-1011 TriStar, an airplane that was so far ahead of its competition design-wise and capability-wise that it became another hallmark of Lockheed achievement. It was fabricated, sub-assembled in Burbank. The assembly line and the delivery operation was at Palmdale in a new facility built primarily for L-1011 production. The airplane, even today, is in use in various parts of the world, and you hear of it having new duties to perform by new operators, new challenges. And it'll be around for a long time as a standard.
The last airplane Lockheed built at the Burbank plant was completed in 1990. It was an F-117A stealth fighter, produced in secrecy like many of its predecessors by the Skunk Works.
Now, the stealth fighter, as it turns out, will be the very last complete, total design, fabricated, built, assembled airplane on our Burbank property. It will have, for its lifetime, the signature of Ben Rich, endorsed by Kelly Johnson. And by a strange coincidence, I must add that the wingspan of that little F-117A stealth fighter is exactly the same wingspan of the original Lockheed Vega, 42 feet. Just to harken back to the genesis of Lockheed, the incubator days of the old plywood Vega. And I'm sure Ben would acknowledge that the chain of development and the heritage of Lockheed has inspired him, as it has all of us, to continue to come forward with the best that there is that Lockheed has to offer.
Within months after production was completed, Air Force stealth fighters were flying combat missions in the Middle East, writing another chapter in Lockheed's development of advanced airborne technology. Among the facilities vacated in 1991 was one built in 1941 that was used for decades as headquarters.
This building, just across the street from the airport, served as the headquarters, the home, and the heart of Lockheed. It was first or initially occupied by the Vega Company, followed by the Lockheed California Company, then the corporate headquarters, and finally is the home of the Lockheed Aeronautical Systems Company. This building was the headquarters of our pioneering chairman of the board, Robert Ellsworth Gross. Robert Gross was a great visionary. He saw the potential in the future of our company. He was followed then by his brother Cortland, who Robert Gross always gave credit to for the man that got the job done. Cortland then was followed by an outstanding young man who came to us from outside the company. His name was Daniel J. Houghton. Dan brought a broad experience in leadership and in his strengths that came naturally to Dan, of bringing people together to execute a common project or objective. Then he was followed by a man from outside the industry, Robert Hack. He carried us through a very difficult transition period. He saw the strengths in our company, and he pointed out to us those areas where we could be even stronger. Roy Anderson came to us with a financial background out of Stanford University. Roy brought to us his abilities to select and develop people and put a team together. Roy then was followed by the last chairman of the board to occupy this now famous building. His name is Larry Kitchen, a fighting Marine. Larry didn't know how to use or spell the word quit. Larry was a man who got the job done and who put the team together and developed a common objective.
Corporate headquarters moved from Burbank to a new location in 1986, and soon decisions would be made to vacate the once bustling manufacturing buildings as well.
Change, it goes beyond our changing of our product. It goes beyond the changing of our facility requirements to keep up with technology. Therefore, when we restructure our company to meet the changing times and the ambient environment or conditions we work under, both contractually, both market-wise, both in our product lines, we must be sure that to survive as a viable company ready to take on new and yet unknown responsibilities will require us to accept change as gracefully as we can, knowing that in some instances it could be a hardship. On other instances, and these are the ones I like to think about, they create new opportunities. I'm reminded of one statement that goes with just what's happening today in our restructuring of our company and our facilities. It's Robert Gross's statement. He said early on, when you work in the field of the air, you instinctively look up, not down. You instinctively look ahead, not back. You look ahead where the horizons are absolutely unlimited. And looking ahead is what we must do today, and accept change, and accept the need to grow and to take advantage of the changing times and the opportunities they make available to us.
Harvey Kristen returned to the old plant site for a last look at the vacant buildings where Robert Gross had his original office at Lockheed.
These 50 years of association with our dear Lockheed has been an adventure in friendships and relationships of the greats of our company and the greats who flew our airplanes. This then teenager will cherish those memories forever.
This is Puff, the Magic Dragon, the oldest and the newest weapon in the Air Force. In 1964, at Wright-Patterson Air Force Base, engineers conceived the idea of converting the C-47 Goonie Bird into a side-firing gunship, mounting three 7.62 Gatling-type miniguns capable of firing 18,000 rounds per minute. The conversion was carried out and proved successful in combat. Now Puff has a big brother, the C-130. It uses the same idea in a more sophisticated manner. It can hunt for and find its own targets, then deliver a smashing and lethal punch that has also been proved in combat. This C-130 was once a reliable, sturdy, hard-working, cargo-carrying aircraft. But now, in Vietnam, it plays the role of a night prowler, covertly seeking out the enemy with its electronic eyes, then destroying them with a devastating, side-firing rain of firepower at the rate of 34,000 rounds per minute. But before Big Spooky could be sent to Southeast Asia, months of modification and testing were required. The modification was performed by the Deputy for Flight Test, Aeronautical Systems Division at Wright-Patterson Air Force Base. Testing was done at Eglin. The avionics laboratory constructed the fire control system, and the Deputy for Limited War was overall program manager. One of the first changes was the opening of the fuel tanks and the packing of them with pieces of inerting foam. Each piece has been pre-cut to fit a specified place in the tank. The foam will inert the tanks of fuel to the explosion that could result from incendiary ground fire. Flooring sections, too, were removed and fitted with armor underneath to take and absorb direct hits from small arms ground fire. An aluminum booth for the sensor crew was also constructed with about 2 inches of Celotex and a layer of sound-deadening acoustic tile. This was installed in the center section. The booth reduces aircraft noise about 45 decibels for greater concentration on sensor imagery and instruments. Its floor is also armor-plated, and the curtains around it are ballistic felt as a shield against flak. Big Spooky's side-firing firepower comes from 4 of these 20-millimeter Gatling-type guns mounted on rigid fixed platforms, plus 4 7.62 miniguns, which have proved so successful on Puff, the Magic Dragon. A large hole was cut in the fuselage for installation of a side-looking infrared sensor, one of Big Spooky's electronic eyes. This is the scanner head. The mirrors are part of the system that detects minute differences of temperature, turning them into a visible picture even in total darkness. A Beaumark A radar was modified and then installed to be side-looking as another Big Spooky sensor to make possible all-weather support to friends on the ground by firing at targets offset from ground beacons. A night observation device called NOD was also installed in the aircraft. In effect, this is a nighttime telescope that magnifies light by a factor of 1,000,000. An onboard illuminator is another important element of Big Spooky's ability to search for and find targets at night. The top of the nighttime light source is an ultraviolet filter. The center is a 20-kilowatt xenon lamp that produces more than 700,000 lumens, capable of illuminating targets more than a mile away. The bottom is an infrared filter used for covert illumination when it's too dark for NOD to see. The illuminator can be pointed fore and aft of the aircraft and also from side to side. After serving its purpose from the aft end of the aircraft, about 4 feet beyond the end of the ramp, the illuminator can be brought back into the aircraft and stowed in a position for immediate use when needed. The sensors, guns, and inputs from the operators are all linked together through a computerized fire control system that drives the reticle of the pilot's gun sight mounted at a side window. When the moving reticle centers, the pilot knows his guns are on target even though he can see nothing below. Upon completion of many of the first modifications, the aircraft was flown from Wright-Patterson Air Force Base to Eglin Air Force Base for its first flights and static test firing. It was here at Eglin that several faults in the modifications were discovered. For example, the 20-millimeter gun mounts that had been specially fabricated allowed gun whip that brought about a pattern of widely scattered hits. This required stiffening the gun mount and beefing up the base plate. This change in the gun mount proved satisfactory. Airborne firing was also satisfactory, and the fire control system was ready for test. The pilot controls everything. He flies the aircraft, he aims, he fires the guns he is called for. The lines are the pilot's fixed reticle. The 4 square dots are the 24-foot square target showing hits close by. An onboard camera shows the 20-millimeter cannon striking very close, then circling the target. On this pass, the pilot called for activation of the 20-millimeter cannon by the master gunner. When on target, the pilot merely presses a button on the control column to fire the guns. Four short bursts almost destroy the target. This was only one 20-millimeter cannon using high explosive incendiary rounds from a distance of nearly a mile. Again, all 4 bursts were right on target. This firing is not a miss. It shows how 20-millimeter cannon fire can be laid down to protect friends on the ground or tear up a quarter-mile of trucks on a road. Big Spooky's flare launching capability, which is used to accompany and augment the night illuminator, was also tested at Eglin. It carries 24 Mark 24 flares in an LAU-74A launcher, and when each flare is ejected, it falls to a preset altitude, then pops open on a parachute. Upon opening, it produces about 3 million candle power of illumination while it floats slowly down. The LAU-74A launcher greatly reduces a potential fire hazard. In the event of a hit on the flares, the launcher with all its flares can be quickly jettisoned. Next came the preparation for night missions. Now let's go inside the aircraft to see the many different actions taking place. The master gunner is at his station to activate the guns required. The infrared operator uses a control stick to direct the sensor head in a search for targets. When one is spotted, he keeps the crosshairs on target, and the information is automatically fed into the pilot's fire director system. This information is also given to the nod operator. Then the 2 operators can confirm, bracket, and pinpoint the target. The sensor operators in the booth hold their scanners and trackers on target while the pilot maneuvers the aircraft to superimpose the fixed reticle on the computer-generated moving reticle to pinpoint the target. With the reticle centered, he fires. First, the front guns, then the rear, then front, alternating the pattern of fire. Every tracer seen represents 5 rounds on target. The first AC-130, called Big Spooky, was deployed to Southeast Asia on 15 September, where it flew more than 70 missions. In just 1 week of night interdiction missions in Laos, Big Spooky proved its devastating effectiveness. On 7 sorties along the Ho Chi Minh Trail, the enemy's main avenue of communications and supply, it destroyed 23 trucks, damaged 8 more, set off 22 secondary fires and explosions, and knocked out 3 automatic weapons positions. Big Spooky has clearly demonstrated under combat conditions that a new dimension has been reached in night attack operational capability. Its impact is certain to be felt in future Air Force systems and tactics.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunk Works' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the Dronescapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.